This video is going to get you ready for the part of the quiz dealing with 6.6, which is using synthetic division and a combination of factoring and sometimes a little bit of both to help us define all of the zeros that exist with a polynomial. So we're going to walk through everything that happens when it comes to how you do synthetic, what the graph looks like, how the graph helps you, and then finally how you should write your answer and prove accordingly that you have these particular zeros. So I have two problems that I'm going to go through with you, and I include what you're going to see on your calculator to help you as well. So the directions here want you to use the graph to determine your possible zeros, and then we're going to use synthetic division and or factoring. You definitely could do both to prove that any real zeros that occur. So when you notice real zeros, what you'll notice is I do not need you to find any imaginary zeros. We'll talk about whether there are any, but you do not need to find where those are. So we have our function. Your first step with these is you need to look at the graph. So pull out your calculator, and you're going to go to y equals, and you're going to type in your function. Now, just to save time, I had already typed this in before I started making this video. And so you can see here is my polynomial, 2x cubed plus 15x squared plus 22x minus 15. And you do want to make a quick check. Make sure your signs are right. Make sure you didn't forget any x's or any numbers, or else you'll be looking at a different picture and it'll throw your entire problem off. Once you're sure that everything looks good, hit the graph button and take a look at your polynomial. And what you are looking for is you're looking for places where your graph crosses the x-axis that look to be integer zeros. So I don't really want to worry about the one that looks like it's somewhere between 0 and 1 right now, because it's not something that I can easily pick a number and do synthetic division. So I'm going to pick, if I look at my graph, I'm going to pick either -3 or -5, because to me those are ones that look pretty obvious that that's where it crosses the axis. So I'm going to start my synthetic division process by setting up the box, so putting the coefficients across the top, choosing one of the zeros. It does not matter which one. I thought that -3 looked like a 0. Go through the synthetic process, and what should happen is you should get a 0 remainder if you correctly did the synthetic division and had the right 0. So drop down the 2, multiply -3 times 2, that's -6, and you get 9. Multiply -3 times 9, you get -27, add, you get -5. Multiply -3 and -5, you get 15. Add, you get 0. And right now you should be feeling pretty good about this because you got 0 as a remainder. So you have just proven that -3 was a 0. Now you have a couple options. One option is, at this point, just write down what you have and factor it. So I'll actually go through that on this one, and then I'll show you the other option on the next one. So I'm going to write down that 2x squared plus 9x minus 5 is my resulting polynomial. What I did is I took my original power, my cubed, and I dropped it down 1 power. So that tells me this is your x squareds, this is your x's, and this is your constant. And now I'm going to factor. And I know that it should factor because visually I saw other intercepts. So I've got 2x and x, and I'm going to have plus 5 minus 1. You can do a quick FOIL to make sure that it really does factor that way. So that tells me that my zeros are +1/2 and -5. And I already found -3. So I'm going to list over off to the side. Here are my zeros: -3, -5, and 1/2. In any order, doesn't matter which ones. And what I've done is I've proven them by either using synthetic division, that's what I use for -3, or factoring, that's what I use down at the bottom. And visually, if you look at your graph, that should match with what you see. You should see that there are intercepts at those 3 values that you just listed. And you've proven it to me. You haven't just relied entirely on the picture. Notice this one did not have any imaginary zeros. We had a degree 3, and we had 3 real solutions. The next one is also a cubic, and we're going to be asked to do the exact same thing, so I am going to have to graph it. And this one I don't have ready to go in the graph, so I am going to have to clear out my old one and type it in. So type in your polynomial, and again, make sure you don't mistype anything, because if your picture is not accurate, your entire problem will be thrown off. Hit graph, and I see 3 zeros. Degree 3 makes sense. I see that 2 of the 3 are not ones that I'm going to try to do any type of synthetic with. Really, the only one to me when I'm looking at this that looks like a good one to work with would be 4, +4. It looks like the other 0 falls somewhere between 2 and 3, and the other 0 falls somewhere between -2 and -3. Neither of those I really want to mess with. So I am going to do synthetic division with 4. So I set up my box, put a 4 outside, drop down the 1, multiply and add, multiply and add, multiply and add. And I do indeed get a 0 remainder, so 4 is a solution. At this point, there was nothing else synthetically that would help me, so I'm going to write down what I have. I have x squared, and I have minus 7, and I need to figure out when that equals 0. Now, you'll notice it's not a whole number. It's not an integer. It is not even anything rational. But I can solve this using what I know about square roots. I'm going to add 7 to both sides, so I get x squared equals 7. Then I'm going to take the square root of both sides. So my other two solutions are plus or minus radical 7. And that's why when you looked at the picture, you saw two zeros, but you really had a tough time kind of giving a name to those zeros because it was the square root of 7, which is not something that you're going to know exactly what that is off the top of your head. But you can see that 0 happening there. If you wanted further confirmation, you could go to your calculator, you could hit the trace button, and you could type in the square root of 7, and you would see that 0 right there. So you could actually see that. Again, the calculator provides a way to get started, and it also gives good confirmation, but it's not proof. The proof is you either did synthetic division, you did factoring, or you did some sort of combination to prove to me exactly where those zeros are. So this one has 3 zeros. One is an integer 4. The other two are plus and minus radical 7. So if I had to come off to the side, I would write this as my final answer. Here are my 3 real zeros. So this gives you an idea of kind of the end of this section. We start with the basic polynomial long division, we move to synthetic division, and then we really give it a purpose. Here's what synthetic division really does for us. It helps us prove where zeros occur on graphs of polynomials.